B. Satvik. Hello everyone, my name is B. Satvik. I am from CSC section, and today my topic for discrete mathematical structures concept video is well-formed formulas. And today we are going to learn about well-formed formulas and some examples of it. This is a well-formed formula. In a mathematical logic, propositional logic and predicate logic, a well-formed formula abbreviated to WFF or WFF, often simply formula, is a finite sequence of symbols from a given alphabet that is part of formal language. Mathematical logic. Mathematical logic consists of statements, notations, connectives, well-formed formulas, truth tables, tautology, equivalence, implication, normal forms, disjunctive normal forms, conjunctive normal forms, principal disjunctive normal forms, principal conjunctive normal forms, and etc. Predicate calculus consists of predicative logic, statement functions, variables and quantifiers, free and bound variables, rules of inference, consistency, proof of contradiction, automatic theorem proving. Mathematical logic. A statement or a proposition is a declarative sentence that is either true or false but not both. Assertion is a confident statement of fact. An assertion is a statement. It is different from asking a question or giving an order. Uppercase letters denote propositions. Logical connectives. Use logical connectives to add two or more propositions. Words or phrases like not, or, if, then, if and only if are called logical connectives. The new propositions obtained by the use of connectives are called compound propositions. More compound propositions can be built from simple propositions using logical connectives. Connectives. Logical connectives consist of negation, conjunction, disjunction, exclusive or implication by conditional. Negation. A proposition denoted by inserting the word not at an appropriate place is given proposition is called the negation of given proposition. The negation of P, proposition P, is denoted by negation of P. It's read as not P. Conjunction. A compound proposition obtained by combining two propositions by inserting the word and in between them is called conjunction of the given proposition. The conjunction of two propositions P and Q is denoted by P and Q, read as P and Q. Disjunction. A compound proposition obtained by combining two given propositions by inserting the word or in between them is called the disjunction of the given propositions. The disjunction of two propositions P and Q is denoted by P or Q, read as P or Q. Conditional or implication. A compound statement obtained by combining two given propositions by using the word if and then at appropriate places is called conditional. If conditional, the conditional if P then Q is denoted by P tends to Q, and the conditional if Q then P is denoted by Q tends to P. It is important to note that the conditional Q tends to P is not same as the conditional P tends to Q. Conditional or biconditional or by implication. A compound statement obtained by combining two given propositions by using the word if and only if at appropriate places is called a conditional. The conditional if and only if is denoted by P by implies Q. Well-formed formulas. While representing a statement involving connectives in symbolic form, care has to be taken to ensure that the symbolic representation conveys the intended meaning of the statement without ambiguity. Appropriate parentheses are to be used at appropriate places to achieve this objective. For example, the negation of the conjunction of the propositions P and Q must be symbolically represented as negation parenthesis P and Q parenthesis. Negation P and Q, because negation P and Q can also be interpreted as negation P and Q, which is not intended to be an statement. Statements represented in symbolic forms which cannot be interpreted in more than one way are called well-formed formulas. If the statements are said to be well-formed formulas, it should follow the three important rules. A statement variable standing alone is well-formed formula. Example P, Q, R. If P is a well-formed formula, then negation of P is also a well-formed formula. Negation of P, negation of Q. The conjunction, disjunction, exclusive disjunction, conditional and biconditional whose compounds themselves are well-formed formulas. Examples. Example 1. Let P a circle is conic. Q root 5 is an irrational number. R exponential series is convergent. B the propositions. Express the following compound propositions in words. P and negation of Q. P negation of P or Q. Negation P XOR negation of Q. P tends to Q XOR R. Negation of P by implies Q and negation of R. P and negation of Q defines a circle is conic and root 5 is not an irrational number. Negation of P or Q implies a circle is not conic or root 5 is an irrational number. P XOR Q negation Q describes either a circle is conic or root 5 is not an irrational number. P tends to Q XOR R implies if a circle is conic, then either root 5 is an irrational number or exponential series in convergent, but not both. The last and the final one, negation of P by implies Q and negation of R tends a circle is not conic if and only if root 5 is an irrational number and exponential series is not convergent. Here we come to the end of the concept video. I hope you got to learn about the well-formed formulas and propositions and the other things. Thank you.